Okay, this is the practice test for Mat 1100, Chapter 3. In problems 1 through 4, you're naming the x and y coordinate for each of the points that have been named, and there is no work for each of these. Point A. Point A is 1, 2, 3, 4, 5 spaces to the left, meaning it's a -5, and it is 4 spaces up in the air. So the x coordinate here is -5, +4. Problem number 2, point E. Point E is 4 units to the right, meaning +4. And it is 3 units up in the air, so +3. Point G. Point G is -3 spaces to the left. It has no height either above nor below the x-axis, so that y-coordinate is 0. So -3, 0. Point F. Point F is located 2 units to the right, meaning +2, and it has no height either above nor below the x-axis. So the y-coordinate is 0. Completing the ordered pairs. You're going to need to show the work for each one of the pairs that you complete, and I need to see all that work on the test as well. So for the first point, it says that you are supposed to complete 0 and give its partner. Since the 0 is in the x position, that means that you're going to be plugging this value in for x, looking for the value of y, and you use the equation to plug in. So it's 3 times x is equal to y minus 3. 3 times 0 is 0. Copy down the y is equal to 3 and move this 3 to the other side, at which point it changes sign. So this is gone. It's the same thing as adding 3, and you have that the y partner is 3 when the x value is 0. So that's one bit of work. And what I just did here, you need to do for the other 2 points as well. Show the plug-in and how you solved the equation after you plugged in the value. Next one you're completing is 0 in the y position, and you're looking for the x. So again, go grab the equation. This time you're putting the 0 in for y. So it's 3x is equal to 0 for y minus 3. I'm just using this equation each time. 0 take away 3 is -3. Here you have a 3x, so you're not only substituting, but you're also showing that you know how to solve the remaining equation. Here would be division on the last step, giving you a value of x equal to -1. That's the x partner that goes right here. Continuing with the last point. You're given a point that has a 3 in the front, meaning they've given you the x and you are looking for the y partner. So again, copy the equation. You just have to be careful to plug the number that they're giving you into the right position. If it's in the front, it's an x, and if they give you the number in the back, it's the y. So again, the equation is 3x, they've given you a 3 to plug in for x, is equal to y minus 3. So you substitute, do the arithmetic to get the value, and then show that you know how to solve the remaining equation. Here you would have to move this -3 to the other side, causing it to become a +3, and your answer is 12. Okay, moving on to number 6. In problem number 6, you're being asked to graph the equation, or let's see, no, you're doing the same thing. You're completing each of the ordered pairs, and then you're graphing the equation. Let me go back to number 5 because I don't think I actually finished that one. I got all the points, but I didn't plot them to get the graph, and you need to do that as well in 5 as well as 6. So let me go ahead and plot those points. I got 0, 3 when I did my calculation. I got -1, 0. That's right there. And I also had 3, 12. So 1, 2, 3, go all the way up to 12, or just approximate that, and then connect the points to produce the graph. So don't forget to do that as well, unlike what I just did. Okay, going to number 6, you're doing the same thing. You're going to show the calculations, and then from the points you calculate, you'll get the graph. Once we get to 7 and 8, we'll be graphing a different way, a much shorter way. Okay, but for 5 and 6, this is how you do it. You're going to complete the first point they've given you where there's a 0 in the front. You're using this equation. The 0 is in the front, which means it's an x. Therefore, you need to put it in for x. Okay, anything times 0 is just 0. Drop down the -1, and you get -1 for your y value. So the partner that goes with this is -1. Okay, next point they give you, there's a 4 in the front and nothing in the back. So since this is in the front, it's an x value. Again, grab the equation, and where there was an x variable in the equation, you place the value that they've given you for x. Now, 4 is the same thing as 4 over 1, and since you have a 4 in the numerator as well as the denominator, they cancel, leaving you with the remains of 3 over 1, which is just 3. Take away 1, equal to 2. So the partner that goes with this is 2. Moving on to the last point, you have -4, and you're trying to find the partner. Okay, so this is going to be y is equal to, again, that's the x value because they've put the number in the front. 3/4, put this -4 in for x, -1 is the rest of the equation. Again, 4 is the same thing as 4 over 1. Only difference between this answer and this one is that there's a negative, but the 4's still cancel. The negative has nothing to cancel with, so it's going to hang around once you do this product, which just means you're reporting the remains, which are 3 over 1 or just 3. -1, you get -4. Okay, so that goes there. And then don't forget, like we did for number 5, to create a graph from these points. So it's 0, -1, and then it's 4, 2. And then it's -4, -4. And then just connect them. That's number 6. 7, these you can graph using the y-intercept and the slope. That would be the easiest way rather than making a table of values. And even though we didn't put these values in a table, you could have put them in a table. But rather than doing all this plug-in, you should know that the form of an equation, when it's ready to graph, will look like this. The y-intercept will be back here, and it is where you start the graph. And because it's considered the y-intercept, it is actually a point on the y-axis. So your graph is always going to start there. Now this one doesn't have an extra number out to the end, so that's the same thing as having a 0 there. So the actual starter is 0 on the y-axis. The number that you see in front of x needs to be written as a fraction, because that fraction, the top will be the rise and the bottom will be the run. So that's what we are going to do to the number in front of x. It is called the slope. Okay, so 3 can be written as a fraction like that. The top is what we call the rise. Has to do with your vertical movement. Okay, and since it's positive, we will be rising up rather than down. The bottom number, the denominator, is the run, which is equal to 1. When it's positive 1, we will run to the right as opposed to the left if it had been a negative. Okay, so all we need to do now that we have already plotted the y-intercept is to now enact the slope. Okay, so from the point that you just graphed, you're going to rise up 3, run 1, and you actually only need 2 points to get a graph. You can keep using the slope over and over again if you want to. but really just 2 points will do it. Okay, likewise for this problem, I'm going to do it the same way. This is your starter, also known as the Y-Intercept. This is how you get out of creating a bunch of values like we did in numbers 5 and 6, where we did all this plug-in. We're not even having to do that. So we're going to start at -9. Remember, it's a Y-intercept, not an X-intercept, so make sure you plot that point on the Y-axis. Then these numbers are the rise and the run. So I'm going to use the negative with the top. So rise is equal to -2. So rather than go 2 up, we're going to go 2 down. The run is the bottom of the fraction, which is 9. So when you run, you can either run to the right or to the left, and since this is positive, we will be running to the right. So after you enact these 2 moves from the point that you started with, you will have the entire graph. So we're going to rise down 2. Down 2. That's what that negative means. 1, 2. Hold right there, but don't plot the point. Now do the run. By the time you do the run, you're right here, right there. And now just connect them. And there's your line. That's all the way up to number 9. Okay, numbers 9 through 14, you're doing the slope, and there's a formula. Whenever you have 2 points, you're going to use the 2-point slope formula. There's actually 3 different ways to get slope, but the way that you do it when you have 2 points is like this. Slope is equal to, let me move this out of the way so I could actually do my work here. Slope formula. Don't forget to make your formula card for this test so that in case you need formulas such as this one, you don't get the problem wrong just because you didn't know the formula. Okay, so doing number 9. Number 9, the slope is, I would put those minuses in first just to cut down on the mistakes. And you can actually start with the numbers in the first point, or you can start in the back and then move to the front. Just keep the same direction once you do choose a direction. On the top, the formulas say that you need the y's. I'm going to go -8 and then 6. -8, +6. Then I'm going to use my x's on the bottom like the formula says, -5 and -8. Notice that both times I moved from the front point to the back point, keeping the direction the same. So my x's are -5 and -8. That's why I suggest you put the minuses in that come from the formula first so that you're more apt to notice double negatives. Here I would probably rewrite this first before actually calculating it. It's -5. A double negative combines into just a single positive. So on the bottom you're really doing -5 plus 8, which is 3. On the top, -8 combined with -6 is -14. Okay, number 10, I'm going to have to move to scrap paper in order to do the rest of these. Again, slope is y's on top, x's on bottom. The y's here are 0 and 2. The x's are 7 and 0. And again, I moved from the front to the back. You can do it back the other way. You'll get the same answer as long as you don't make any arithmetic errors. 0 take away 2 is -2. 7 take away 0 is 7. And that's your slope. Okay, moving to number 11. Number 11, slope is going to be y's on top. My y's for number 11 are -3 in the front point, +2 in the back point. My x's are +6 in the front point, -3 in the back point. I have a double negative on the bottom, so the bottom really reads 6 plus 3. So the bottom is 9, and the top is -3 take away 2, negative 5. Moving to get some paper. Moving to number 12. So in problem number 12, the slope is going to be, let's see, the y's are 1 in the front point, 6 in the back point. And then the x's are positive 5 in the front point, 6 in the back point. You know, you can print off a clean copy of this practice test by just going onto Blackboard, going into the content folder where you can find the study guides, and there you can print off a clean copy of this test. But it is 12 pages or at least 11, something like that, so you're going to need a little bit of paper there. Okay, so now this becomes 1 take away 6, negative 5. 5 take away 6 is negative 1. Slope turns out to be 5. Because these negatives cancel. 13. Notice how I always put the minuses in first, so I'll catch any double negatives that might be occurring. Excuse me. So the y's in this problem are negative 3, and also negative 3 in the back point, and then the x's are 4 in the front point, negative 9 in the back point. Lots of negatives here. See, the top is really negative 3. Just rewrite it just so you can focus. Negative 3 plus 3, 0 on the top. The bottom is really 4 plus 9, which is 13. But regardless of what the bottom is, when the top is 0, the entire slope is 0. Okay, 14. 14. Minus is in there. The slope is, y's on the top. The y in the front point is 5, and the y in the back point is 1. The x's are negative 1 and negative 1. There's a double negative in the bottom, so I'm going to rewrite it. Probably best if you rewrite it before you actually calculate it. That'll also cut down on mistakes. Negative 1 plus 1 is 0, and when the 0 is in the bottom, you can try putting this into your calculator. If you went 4 divided by 0, you would see that your calculator gives you an error, meaning that this is undefined. Whereas when you enter the numerator as a 0 divided by a number, that actually is a operation that's allowable, and you get 0. So the difference between 0 and an undefined answer. Undefined, 0 is on the bottom. Okay, moving to the next section of problems. 15, you're using the graph in order to get the slope. So when you're using the graph to get the slope, all you have to do is think about the definition of slope being rise over run. This is how the slope is defined if you have 2 points. You actually have to use a formula. But if you have a graph, you can just slide with your finger in between the 2 points that they have darkened in, or any 2 points that you desire. They just tried to make those obvious. And ask yourself, how much do I have to rise to get from this point to this one? And then how many do I have to run to actually get on top of it? So the rise would be, I'm going to try and travel from this point to this one. Okay, I'd have to rise 1, 2, 3, 4 to get level with the point. So my rise is 4. And then to actually get on top of it, I'd have to run 2 spaces. So the slope ends up being 2. Whoops. Goes right here. The answer for 14 was undefined. Okay, same technique. By the way, when the line climbs to the right, that's called an increasing line, the slope will be positive, and when it climbs to the left, it's going to be negative. It's kind of as a check that you're doing it right. Remember, when you're doing rise and run, your rise is positive if you're going up. It's negative if you're going down. Rise can either mean up or down movement, vertical movement. Same thing with run. If you run to the right, you're going to be positive. If you have to run to the left, it's going to be negative. So again, let's try and make our way from one point to the next. I'm going to start here. It doesn't matter which one you start at. Just make your way to the other darkened in point. Okay, and I'm going to try and make my way to this point by rising and running. Now notice that to get from where I am right now, which is at a height of 3, I would have to rise in a negative manner. That means you're falling. That would be 3, 4, 5, 6, 7, 8, 9 to get level with this point. Then from where I'm at, I'd have to run 1, 2, 3 to get on top of it. Okay, so one more time. You'd have to drop 3, and because you're dropping, that rise is negative. You'd have to drop 3, 4, 5, 6, 7, 8, 9 spaces. That would get you level with the point, and then to get on top of it, run 1, run 2, run 3. So your slope ends up being -3. Here it was 2. Okay, but in these problems I didn't use a formula like I did there. This is more work. Okay, then this one is the least amount of work. When they give you an equation rather than a graph or a couple of points, this is the least amount of work, because just knowing this formula, that when equation is solved for y, everything's first degree, that f of x is the y. Whenever you're given something that, like what you've been given here, it's y is equal to, and then they have 1/6 x plus 8. That comes from this formula right here that I have mentioned in the previous problems on this review. This is your y-intercept, as I called it when I was graphing, and this right here is your slope. Okay? So when they ask you what is the slope is 1/6, and the y-intercept is 8. And if you want to, you can write the y-intercept like this. Anything that's on the y-axis, this number goes in the y position, and its x-partner would be 0. All points that are on the y-axis have a 0 in the front and then some number in the back. Okay, that takes us to 17. Same thing here. You're to find the slope and the y-intercept. So this will, 18, 19, and 20 will be no work, just like 17 was, and you're going to use that same concept. The number that's out here at the end, now this one did not have, number 18 did not have a number out at the end. That's the same thing as having +0. So the y-intercept is the 0, and then always the number in front of the x, the coefficient of x, is the slope. So your slope is 3, and your y-intercept. Please be specific about which is which when you give me the answers on the test. Use M for slope, B for y-intercept. Here, the slope is 3, again the coefficient, and this is the y-intercept. You could actually use those things to get the graph. Here your slope is, I'll do that first I guess since I've been doing it like that, -5, and then your y-intercept is 2. Okay, so 3 different ways to get slope. Number 21. When a tow truck is called, the cost of the service is given by the linear function 2x plus 45, where y is in dollars and x is the number of miles. So you're talking something like this. This is your x-axis, and that's in dollars. And then your y-axis is in, whoops, I did that backwards. I'm sorry. Fix that. It said y is in dollars. I put that on the x-axis. So your x is in miles. And your y-axis right here is in dollars. Okay, so it says find and interpret the y-intercept of the linear equation. Again, this is the slope, this is the y-intercept. So y-intercept is always a point that's right on the y-axis, and it can be written like this. They said that it's at 45. That's what the equation says, that the y-intercept is at 45. So any y-intercept can be written just like this. Writing it as a point like this will help you to interpret it. So when it says interpret what this means at 0. 0 is in the x position. Anything from the x-axis stands for miles. So at 0 miles, so you're turning these numbers into more or less a sentence. At 0 miles, the cost, this is before they even start towing the truck, the cost of service is $45. So that would be like just to come to the location where the car is. They haven't really even towed it anywhere. Okay, number 22. The monthly cost of a long-distance service is given by the linear function 0.04 times x, where x is the amount of time in minutes. I think it'll help you concentrate if you take the words out of this little paragraph and put it in the form of an XY axis. Okay, and then x is the amount of time in minutes, which I put there, and y, this y axis, is in dollars. Okay, then again, they said find and interpret the slope and the y-intercept. And let's see, I think I was supposed to do the slope for the last one too, but let me just finish this one. So the slope here, the slope, which is equal to 0.04, let's talk about where a slope comes from. You can say that slope is defined as rise over run. The rise has to do with the y's. The run has to do with the x's. So what you want to do is look over here at this xy axis and ask yourself, well, what is the rise all about? What is the y-axis about? It's about money. So it's the cost in dollars, if you want to put that dollar sign. You don't have to. It's the cost in dollars compared to the number of minutes. And you can give that as a description. So the slope, when they ask you what the slope is for number 22, the slope, which is equal to 0.04, is and you can write that as itself over 1 to even give a better explanation, is actually the cost, and you could say compared to, but you could also use this word, the cost per minute. That fraction bar can be written using the word compared to, or I like to use the word per. It's the cost per minute, because 0.04 refers to the top is the cost, and the bottom number is the number of minutes. So it's the cost per minute, rise over run. And then they also wanted you to explain the y-intercept. So the y-intercept is the $8.95. And the y-intercept can always be written like this, 0 and 8.95. You can write it as a point. So when you're interpreting it, you can say, let's see, this stands for the x's. X's has to do with minutes. So you could say at 0 minutes, when you hadn't even used any minutes, the cost was $8.95. I'm going to have to move the rest of these to paper. That gets me up through 22. Let me complete 21. 21, they also wanted us to talk about the slope. So when you were looking at the slope in this problem, your slope was 2. For number 21, I didn't answer that question. The slope was 2. 2 is the same thing as 2 over 1. And you have to think of this as rise over run. Rise referring to the y's, this referring to the x's. So look at this little picture here and you can see that this is cost per miles. The rise or the y's refer to cost and this refers to miles. So it's the cost per mile. Cost of $2 per mile. Okay, and that's all the way up through 22.